Hello and welcome to this video of Maxwell Simulink and Simplorer co-simulation. I am Shaptarshi. So here's a small motivation behind this video. Why we need a co-simulation. When we need to do a electromagnetic simulation in a closed loop control, we need to have three modules for the simulation. Now, Ansys Simplorer can also employ some control, but Matlab Simulink is much better and user friendly. So that is why this video. The prerequisites are that you can make your own Maxwell, Simulink, and Simplorer projects. I'm not going to describe how to make these projects. I will only show how to link these three softwares. So before we start using this software, so we have to make sure that we have the compatible versions of the two softwares, Ansys and Matlab, installed. To do that, we have to go to the installation directory of the softwares. I will go to the directory of Ansys EM, the electromagnetics, and then go to the corresponding version folder. And there is a folder called CPL. CPL means couple. Then Matlab. So these are the compatible versions of Matlab that goes with this ANSYS Electromagnetics 21R1 version. So the MATLAB version that you have installed in your computer must have a folder corresponding to here. Otherwise, you have to install a compatible version of MATLAB. So these are the supported versions of MATLAB. Now, before we start, we have to do a one-time setup in both the softwares, in both MATLAB and ANSYS. So how to do it? First, I will tell MATLAB where the ANSYS electromagnetics or ANSYS Maxwell lies in my computer. To do that, I will click on set path, and then I have to add this folder. I will show which folder. I have to click on add folder. Then I have to go to the corresponding installation directory of ANSYS. Then the same folder that I showed, MATLAB. And for my case, it is 2018A. So I will select this folder and then click select folder here. Now, since I have already added the folder here, I am not adding it once again. You have to add it. You can see it's here. So that's a one-time process. You add it here and then save. Okay, so now MATLAB knows where Maxwell lies. Now we have to tell Maxwell where MATLAB is. So to do that, you open Maxwell, go to Tools, Option, General Options. Then under General, you go to Miscellaneous. Then here is this Matlab Optimization, the Matlab path. You can see the Matlab path is nothing but the path towards the matlab.exe, the executable file of MATLAB. There is an example also, you can follow this. So I have already added it here. You can follow this example and add your MATLAB path here and then click OK. So these are two are one-time method, one-time process. You can do it once only, right? Next thing is you have to create an electromagnetic simulation. So I have already made a drawing. It's my expectation that you will know how to draw this thing. Now what I will do is how to set up the simulation here. First thing is we will need a transient solution. So solution type transient. I make it transient. After that, we have to uh, assign excitation. So this is the ferrite core transformer, and these two are the windings. We are using it as an inductor of a buck converter. Okay, so these two are the windings. So I will right click on it, then assign excitation and coil. This coil option comes only if you have changed the design, you have changed the simulation type to transient. So I go to coil, I gives a number of turns 100 and keep this positive, and on the other side I assign excitation coil, keep it 100 once again and make it negative. So these two are the coils. Under the excitation you can see the two coils. Now we will add winding. This winding will be external and stranded since we had 100 turns. So this is winding 1. Okay. Now we have to add these two coils to the winding. So we right click on winding, go to add coils and add these two coils. So these two coils are not part of the winding. If I click on the winding, I can see this is the winding. Okay. Then analysis is not important here since we will analyze from Simplorer. Okay, now we will need boundary. For boundary, I will first create this square, then I will delete the cover lines, then assign boundary, vector potential, keep it like this. Then I draw a region of 1% offset. So boundary and region is complete. Okay, so we will again now go to design settings. In design settings, there is one thing is the model settings. I will keep the depth of this model as 5 mm, and this is important. This advanced product coupling enable transient link with twin builder. So I check on it. So twin builder is the new name of Simplorer. Okay, so let me double check once again that the um, it has taken the model settings. No, I gave it 5 mm. Okay, all right. So this is complete. We do not need mesh analysis of the results. Anything else? Okay, so that's all about it. So our Maxwell design is complete. We can close it. Okay, I will open the Ansys software once again, and now I will develop the the Simplorer project. So it will take some time. Yeah. So I have already made it. Since I have already mentioned that I am not going to make these things in this video. So you can understand that the buck chopper is ready. Only thing is the inductor will come here. So how to bring the inductor here? I will go to twin builder, sub circuit, Maxwell component, add transient co-simulation. Then source. I will this browse project will be there. So I click on this thing and I go to where I kept it. This transformer was the Maxwell file, so I import it. So you can see it opens that file here. So I have imported it. Okay, so I need a solution. Have to create a solution here. So I will quickly go here and go on analysis. I will create one solution setup. Millisecond, 100 millisecond. Let us say minus 0.01 millisecond is step time. Okay, so analysis is there. Now we will try to call it once again. Excel component transient cost simulation. So we are calling this transformer. Okay, it's taking longer than usual. Okay, let it be. In the meantime, let us create a blank model in Simulink. It is also taking time. All right. So what we have to do is we have to save this Simulink project in the same folder of where I kept our Simplorer and Maxwell file. In the same folder, I have to keep it. So I kept it in this. cosim folder. I name it controller. So it go and get saved in controller.slx format. Okay, let us see if it is. Yeah, it is there. So if I zoom in, you can see the Maxwell project has come here, and the winding I have given winding one. Its name was winding one. So you get the winding one in and out. If you have multiple windings, you will get multiple ports here, one in and one out port for every winding. So I connect them to, and this is more or less complete. Okay. Okay, one more thing we might need here, that is electrical ammeter. We will wish to see the current through it. So what we will do is we will connect it this way, and I will need a pin. I will need a pin because I want to take the output, and electrical voltmeter also. I will need this to get the output voltage, and here also I will need a pin. Okay, this is the voltage pin. All right. So our Simulink project is more or less complete. Now what we have to do, we have to create a Maxwell, or not Maxwell, a Simulink sub circuit. So I again go to in builder sub circuit, add Simulink component. I click on it. Now I will check this insert file in this project. Okay, and I will browse for the .slx file that I just saved. I will browse for it. So it will insert that SLX file in this project. Now we will add pins to this Simulink block. Okay, since I am only giving an example, so I will not add much pins. I will add say 3 pins. So clicking on this button, you can add pins. Here you can see the description, whether it is to Simulink or from Simulink. Okay, now suppose I get a pulse. So I will control the switch using this pulse. So clearly this will be from Simulink. Simulink will create the pulse, and I say I need inductor current and output voltage. Okay, so these will go to Simulink. So I have to click on this, check these 3 boxes that add pins will come out. I click OK. This Simulink block is created. I close this. So the Simulink block is created. What I can do is, and this is the pulse. You see, this is the output of the Simulink box or block, whatever. So this pulse will go to this switch, and this I out. Well, the circuit will be a bit clumsy. Whatever. Just try to understand how things work. So the I inductor will be here, and the supply volt. Sorry, not supply voltage. Output voltage. Well, so what we are doing, so this Simulink block, we are giving it inductor current and output voltage, and we are getting pulse from it like that. You can keep any number of input and output pins here. I am giving just an example. You can keep any number of pins. Okay, that is more or less done. I've already kept values to all these things. That's it. So this project is more or less done. Now we will go to this Simulink block. Here we will create the project. So what we have to search for? We have to search for is S function, S hyphen function. So we search for S function. S function comes here. I drag and drop it here. It is taking some time. Did it come? My machine is a bit slow. Make sure that two blocks have not come. No. Okay. So this is the S function. This block will actually link to the Simplorer. So you double click on it and you get this block. Here you have to change the name of the S function. Now this is very important. You have to rename it exactly the way I am writing. You have to write Ansoft, A capital, rest small, then S capital, F capital. See how it is written? Ansoft S function, A capital, S capital, F capital. And you click on OK. After you click on OK, you wait for some time. Sim to sim window will appear. This is a sim to sim window. Now we have to click on read link information from file. As soon as we check on it, this window opens. We click on the Simulink file. Buck is a Simulink file. Sorry, not Simulink, Simplorer file. Buck is a Simplorer file. And as soon as I open it, I can see all the pins that I labeled made there, those are here. So I have to now link them one after another. Okay, now this has been created. Now you see, as expected, here we have one input and two outputs. So this block, basically this block represents the the Simplorer project. The Simplorer project takes pulse from here and it gives voltage and current like that. And this block represents the Simplorer project. So I get a scope here. As you can understand, using this current and voltage values, you can employ your own closed loop control. Pulse or whatever. Okay, pulse I have to check. Amplitude will be 1 period. I will give say 1 kilohertz. I become 10 kilohertz. 1 kilohertz and pulse width say 50%. Okay, that's it. Now I add this and I save the project. It is done. Okay. Now we go to the Simulink. Here one thing is left is the analysis, the transient analysis. Let us make it 100 millisecond. The minimum step time, let us make it, since it was 1 millisecond, so 0.01 millisecond will be more than enough. 1 millisecond, not 1, 0.1 millisecond, not less than that. Zero point 0.1 will be enough. Okay. Done. Our project is ready. Now we will run it and see if any error comes, and we will try to rectify those errors. So I run it from Matlab Simulink. It has started compiling. It will also initialize the Simplorer program on the other side. Yeah. Oh, it has already started running. No error. That's very surprising. Yeah. So you can see it has started. I made a mistake. I should have. Can I see the scope now? I don't know. Okay. Anyway, you can see the waveforms anywhere. You can see the waveforms in Matlab also. Okay, the scope finally opened. You can see this waveforms in. No waveform is coming. Okay, we will see. Um, so we'll go to transformer, then go to results, create transient report, rectangular plot. We can see the current. Current through the inductor we can see in Matlab, sorry, in Maxwell. Well, so it went into discontinuous conduction mode. What to do? I did not calculate, but the simulation is running. You can see. Only thing that is left is well, I will run it once again and see what is the problem. Oh, it is coming here actually. Let us, yeah, you can see the waveform both from Matlab and Simulink. So that's all about it. That's how it is done. As I told you that you can use any number of pins. You can now make your own whatever, however complex closed loop control circuit here, and control your electromagnetic simulation from Simulink itself. Okay, that's all about it. Thank you. Thanks for watching.